We are going to discuss very quickly about the term called normalization. Now, this term normalization quite oftenly used in database management system, and that too precisely when we talk about relational databases. So basically, we are going to discuss very quickly about normalization in relational database management system. So basically, whenever we say normalization, there are many ways of normalization. We call it first normal form, second normal form, third normal form, voice code normal form, fourth normal form, fifth normal form, likewise. So we'll start with one of the first and second normal forms, and we'll see why we need it, why it is so important in databases. Normalization simply means whenever we have a large database and it has to be managed, so we try to make it more optimized, more effective and efficient by minimizing all the issues that may come inside. And when we say issue, it simply means the duplicacy of data, and due to duplicacy we may have the inconsistency in the data. For example, if my data is stored in several different records, maybe in passport I have some different data, in the SSN number I have some different data. So it's like for me only two data are existing in two of the government databases, and it becomes very inconsistent. So these are basically anomalies, and with normalization the main idea is to minimize those anomalies so that all the data which is available everywhere should be free from all the anomalies. So the main aim of normalization is to free the data from anomalies. Now, what are those anomalies? It could be insertion, deletion, likewise. Now, when we talk about, let's say we start with the first normal form, call it 1NF, or basically it's a very basic normal form. So first normal form, it simply says the minimum requirement is all data should be atomic. When I say atomic, it means that no data should be abandoned, no data should be orphan. Means let's say consider the database of all the vehicle owners in a city. So what all details we have? We have the vehicle number, we have the vehicle type, which could be car or a bike, we have a make, we have a address, we have phone number. Now let's say we also add something called name of person. Now we have a person called A. He has a vehicle number ABCD, which is a bike make of Suzuki, and he has some address like 9th Bay Street, and he is not managing a phone, he is not having a phone, he is not carrying a phone. So the phone number in this case will be like nothing, it will be blank. There is a second user called B. There is a second user called B, and let's say his vehicle is PQRS. He has a car. Again, this car is of Suzuki. Some address 10th Bay Street or something, and he has a phone 1234. Now if we see these two records, so we see that the record number 1 for the user A, we have one blank record. This is record number B has got all the input. Similarly, this is a very small data set. Consider a database which has got many number of columns, many number of attributes, many number of fields, or let's say millions of data being transacting every time. And if we have this kind of structure wherein some inputs are blank, some inputs are registered, so this makes our database very much inappropriate. Like for example, if I talk about user A, and if I am trying to find out or updating like more information of user A. For example, user A has purchased a new car. Now vehicle number would be something AMNS. Now it's a user A who has got a car. This is make of Honda. The address is 9th Bay Street, but by the time he purchases the car, he also maintains a phone number. So that, let's say 7, 8, 9, 10. Now for the same user A, we see that in one record he is not managing a phone number, in second record he is managing a phone number. Or if we go more into detail, we see we have a database of passport, we have database of SSN number, social security number for the user A. So the user A does not maintain a phone number in passport, but he has a phone number in SSN number. So that makes the data of user A very much inconsistent. How to find out which data is updated or which data is correct? So that's why the very first normal form says that a database or a relational database should have all the records atomic. Means all the records should be containing some values. There should not be anything blank. Either it should have null or some value, but it should never be blank. That is something we do not accept. So no blank input. All records should be atomic. So when we say about this record, then in this case the A will have a null phone number if he is not having the phone number. Now with this first normal form, if we just try to think beyond what is happening here, just try to go more beyond this thing, whatever is happening, we'll observe that for the same persons there could be n number of records being existing, and same number of data will keep on getting duplicated. So once we are able to come in a position wherein we do not have a duplicate record, for example here we are having no phone number, blank entry for user A, but now when we are in a first normal form, we are saying that the user A should have some phone number. It should never be blank. Either it should have some value or it should be null. Now this comes in first normal form. Now still we need to go to the second or higher normal forms. Why? Because multiple records will exist. How to analyze which is the correct one? How to find out which is the right value if I am trying to input more records for the user A? How to validate if the user A has phone number correctly entered or not when the user A has multiple instances? And when we are taking an example, we are talking about 3 records. Just think of 3 million records. In that case, this problem becomes very highly responsible to identify the gaps, and that's why we just try to optimize the whole thing, and we jump on to something called second NF or second normal form. Now when we say second normal form, we have a concept called functional dependency. Now what is functional dependency? Functional dependency is something like, for example, there is a student. If he has an admit card, then only he can give and attend the examination. If he is not having an admit card, he cannot attend an examination. It means having an admit card functionally determines that a person is eligible to participate in the examination. So we can call that admit card functionally determines student, or student is determined by admit card. So similarly, if I say like a person has an ID, a student has an ID. Now in this case, it's not a full functional dependency. I mean, an ID determines a person and ID determines a student. ID can determine both these things, both these attributes. So this is called concept of functional dependency. And in second normal form, we simply say in a given relational schema, if we have multiple records fully functional dependent, we just distribute them into the smaller forms, and so that there is no partial dependency exists. Either it should be complete full functional dependency or no dependency at all. So we'll talk about this in detail, but just to give a quick overview, whenever we talk about the normalization, the main aim is to optimize the operational aspects onto the relationship table, relational database, RDBMS, so that we have operations efficient, optimized and effective while transacting. Once we go to the second normal form, third normal form, fourth normal form, fifth normal form, we'll observe that every time we are just trying to minimize the number of attributes in a table. We are just trying to minimize the table size, but that is not the main concept behind it. It's not always mandate that we have to minimize it. The mandate is there are certain regulations provided by Dr. E.F. Cord, which we are trying to follow while making any database into relational database, and in the normalization we are just trying to use it so as to get the perfect output as and when we scale our whole database. So with this we'll stop here now, and we'll discuss about second normal form and third normal form in upcoming lectures. Thank you.